If I told you that every star you've ever seen, every planet you've ever admired, and even the flow of time itself is controlled by a single invisible force, would you believe me? Today, we uncover how gravity, the quiet architect of the cosmos, shapes the universe from planetary orbits to the darkest, most extreme corners of spacetime. Most people think of gravity as the thing that keeps your feet glued to the ground, but in reality, it's far more powerful. It's the universal sculptor behind galaxies, the catalyst for star formation, and the engine that fuels black holes. And what makes gravity so fascinating is not just its strength, but how misunderstood it still is. Even in the 21st century, many don't fully grasp how gravity works on cosmic scales, especially when dealing with phenomena like dark matter or black holes. So in this documentary, we'll journey from the familiar, like Earth's orbit, into regions where gravity becomes so extreme, it can bend light, stretch time, and rip apart entire stars. And by the end, you'll see the universe not as a chaotic expanse of stars, but as a masterpiece shaped by an invisible hand. Now, let's begin. When most people look at the solar system, they imagine planets gently circling the sun like clockwork. But the truth is far more dynamic. Planets aren't moving around the sun, they're falling toward it. Earth, right now, is in a constant fall. It's moving sideways so fast that it keeps missing the sun. And this balance between falling inward and flying outward is what creates a stable orbit. Gravity defines everything about our solar system: the speed of orbits, the length of our years, and even the tilt that creates the 4 seasons. Without it, Earth would drift into the cold emptiness of interstellar space. Jupiter, the giant of the solar system, acts like a gravitational shield. Its immense mass bends the paths of comets and asteroids, preventing many catastrophic impacts that could have ended life before it began. And yet, even with all this balance, orbits are not perfect circles. They wobble, stretch, and shift over time. Gravity is always negotiating, always adjusting, always in motion. This constant gravitational dialogue is why planetary systems evolve. Some orbits shrink, others expand, and in extreme cases, planets may even be ejected entirely, becoming lonely rogue planets drifting through the cosmos. Orbiting is not stability. Orbiting is controlled chaos, and gravity is the conductor holding it all together. To create a star, gravity takes center stage. Deep in the dark clouds of the galaxy, gas and dust begin to collapse. Gravity pulls everything inward, compressing the cloud like a tightening cosmic fist. The deeper the collapse, the hotter the core becomes. When gravity squeezes hydrogen atoms close enough, nuclear fusion ignites, and a star is born. But this is where gravity's role becomes even more interesting. Every star lives in a constant tug of war. Gravity pulls inward, fusion pushes outward. As long as these forces balance, the star shines steadily. But once the fuel runs out, gravity wins, and the star collapses into something far stranger. Small stars fade into white dwarfs. Larger stars become neutron stars. And the most massive ones? They collapse beyond comprehension, forming black holes. Gravity doesn't just make stars. It decides their fate, their lifetime, their death, and the cosmic materials they leave behind. The next step in gravity's artistry is the formation of galaxies. Billions of stars gather into vast structures, spirals, ellipticals, and irregular shapes. But here's the twist. Galaxies don't rotate the way physics predicts. Their stars move far too fast. They should fly off into space, but they don't. This led astrophysicists to a remarkable conclusion. Something invisible, something massive, something non-luminous is holding galaxies together. We call it dark matter, a form of mass that does not emit light but interacts gravitationally. It forms enormous halos around galaxies, shaping their rotation. Dark matter acts as the skeleton of the universe. Without it, galaxies could not form the way we observe them today. Gravity reveals dark matter not through what we see, but through what we feel. The motions, the clustering, the unexpected stability of galaxy systems. Zooming out, galaxies do not scatter randomly. Gravity binds them into clusters, and clusters into superclusters. This forms the cosmic web, the largest structure in the universe. Enormous filaments stretch across space, while massive voids lie between them. Gravity sculpts this web over billions of years, slowly weaving the architecture of the cosmos. What we see today is the frozen echo of gravity's ancient work, a cosmic tapestry billions of years in the making. Black holes are gravity taken to its absolute limit. When a massive star collapses, gravity crushes it into an object so dense that not even light can escape. This boundary is called the event horizon. Cross it, and you cannot return. Inside, the laws of physics break down. Gravity becomes infinite, space twists, time slows, and our equations stop making sense. Black holes are not empty. They are engines, feeding on matter, heating it, and releasing energy in the form of powerful radiation. Some supermassive black holes launch jets that extend thousands of light years, shaping the evolution of entire galaxies. Einstein predicted this behavior long before we could observe it. General relativity describes gravity not as a force, but as a curvature of spacetime. And in 2019, humanity captured its first real image of a black hole, a glowing ring surrounding a dark shadow, a perfect match to Einstein's predictions. Neutron stars too showcase gravity's extremes. Their mass equals a sun compressed into a sphere the size of a city. If you held a teaspoon of neutron star material, it would weigh billions of tons, all held together by gravity. When neutron stars collide, they produce gravitational waves, ripples in the fabric of spacetime spreading outward like cosmic echoes. In 2015, LIGO detected these waves for the first time, confirming Einstein's century-old theory and opening a new window into the universe. Gravity, it turns out, is not static. It vibrates, ripples, resonates, and now we can listen to it. Modern simulations from NASA, ESA, and institutions like Caltech and Harvard now model gravity's influence on cosmic evolution with stunning precision. These simulations reproduce the behavior of billions of galaxies, the growth of dark matter halos, and even the formation of stars within molecular clouds. Observatories like Hubble, James Webb, and Chandra provide real data confirming these models: galactic rotation curves, gravitational lensing, and black hole accretion signatures. And gravitational wave detectors, LIGO and Virgo, allow us to observe collisions billions of years old through spacetime vibrations. Together, these datasets create a unified picture. Gravity is the sculptor, the regulator, and the storyteller of the universe. Personally, I find gravity to be the most poetic force in nature. It has no voice, yet it dictates every cosmic event. It has no form, yet it shapes everything we see. It doesn't push or pull in a way we can touch, but its consequences are everywhere, in the stars above us, in the ground below us, even in the flow of time passing around us. And the more we learn about gravity, the more it reminds us how little we truly understand about the universe, and how much more there is left to discover. Gravity isn't just a scientific concept, it's the backbone of existence. It forged the stars, built the galaxies, and shaped the cosmic structures we call home. So the next time you look at the night sky, remember, every point of light, every swirling nebula, every distant galaxy, they all exist because gravity allowed them to. If you enjoyed this journey through the forces shaping our universe, make sure to subscribe, leave a comment on what cosmic topic you want next, and share this video with anyone who loves exploring the mysteries of space. The universe is vast, and together we'll keep discovering it.